Mr. Monty here. Welcome back for lesson 6 of our 2020 series. 20 lessons of 20 minutes a day for 20 days in preparation for the placement exam at the community colleges here in Spokane. Lesson 6 is a continuation of domain and range. Let's think back. Our objective was I can find the domain and range given a function. Now, this particular lesson, we're stepping up the difficulty a little bit with more complex type functions. Assuming you've already tried it, you've graphed it with a calculator, and you've seen the resulting shape, which will help us to write the domain and range. I want to attack it from a little bit different perspective and make sure that everybody has the ability to use our 3-column data table to find some specific points. X, the operation, which is the function, and then our outputs y. Let's pick 2 arbitrary values. I want to find where the function crosses the x-axis, where the function crosses the y-axis. That way we can get an idea of what this looks like when we sketch it. Let's plug 0 in. We're going to have 0 squared minus 9. 0 times 0 is 0, minus 9 gives us a minus 9, and that's all divided by 0 plus 3. 0 plus 3 is 3. So minus 9 divided by 3 gives us a minus 3. So our actual coordinate point is 0, comma, minus 3. 0, minus 3. Put a big old spot right there. Now let's try it with an arbitrary value of 3. Let's plug 3 in for x. 3 squared minus 9 all over 3 plus 3. Well, 3 times 3 is 9. 9 minus 9 is 0. And 3 plus 3 is 6, so it's 0 divided by 6. 0 divided by any number is 0. So our second coordinate point is 3, comma 0. 1, 2, 3, comma 0. Put a spot right there. This one was minus 3, 0, 3. Now we have our 2 points. Take our ruler. Oop. Actually, sketch our line. And we see that we actually have something linear. From this, we ended up with a linear equation. Wow, that's kind of strange. Well, if we were to write the domain and range for a line, we've seen that before. It's just all real numbers for the x's and all real numbers for the y's. But it's not that simple. If we were to put this in a calculator, we'd see the same answer. But let's check and make sure that we can actually put these arrows on this resulting sketch. What I want to do is I want to see what we can do with x squared minus 9. What I'm going to show you, if this is confusing, we're going to have some lessons coming up on factoring and simplifying. So, don't worry, we'll get you through. The first thing I do when I see this is x squared minus, I can rewrite this as 3 squared. X squared minus 3 squared. All I did was rewrite the 9. All over x plus 3. Well, there's one of those rules or identities in algebra. When you have a variable squared and a number squared, we can rewrite that as x minus 3, x plus 3, all over x plus 3. The difference of perfect squares. Alright, now that we see this, we can actually cancel. X plus 3 over x plus 3. That's just like multiplying by 1. X plus 3 over x plus 3. We cancel those, and our final answer is x plus 3. So the reason when we actually put this in our calculator, we got a line, is because y equals x plus 3 when we simplify it. Unfortunately, we're interested in the domain and range, not of this, but up here. Now, let's think back in math, and we know that we can never divide by 0. Over here at minus 3, when we plug minus 3 in for x, let's try that right here. Minus 3. We have minus 3 squared minus 9 all over minus 3 plus 3. Uh-oh, minus 3 plus 3 is 0. We can never divide by 0. So we have a problem when it comes to our actual domain. It doesn't work at x equals minus 3. So if we were to actually erase this, continue this line down, we would notice that we have a hole right here. We can never have x equals minus 3. And when we have our range, we have to also pay attention to that. What would it have been? What would the y value be at that spot? Okay? So now I'm going to, in easy terms, write our answer out and say all real numbers except when x equals minus 3, or we can say all real numbers x cannot equal minus 3. Okay? Now, when it's minus 3, we need to figure out what that y value should be. What should the y value be when x is minus 3? Y should be 0? This is kind of confusing at this point, what we should have. Okay? So again, we could say, if we're in a hurry, all real numbers except when x equals minus 3, or we can say all real numbers x cannot equal minus 3. Okay? Let's take a minute and just study that. It's a very important concept. When you do the rest of that worksheet, you'll see other times when we divide. Sometimes we end up with what's called asymptotes. Sometimes we end up with what's called wholes. But it's very important when we write our domain and range that we understand that we need to look for these little pitfalls. Okay? So this wraps up lesson 6, which was I can find the domain and range of a given function. And in this case, we were actually given the function, but we had to simplify it. We had to do some algebra before we could actually write the correct domain and range. That wraps up lesson 6. We'll see you next time for lesson 7.